Okay, at 0, sine is 0. So you have a point at 0, 0. At pi over 2, sine is 1. At pi, it's 0. At 3 pi over 2, it's negative 1. At 2 pi, it's 0. And so it just bounces. You should see a pattern. If you go the other way, at negative pi over 2, it's negative 1, and then 0, and then 1, and then 0. So it just bounces. I tell my kids, sine starts in the sand. If you're standing here, this is like the sand. You're on the beach. The domain is all real numbers. The range is from negative 1 to 1, because the highest it goes is 1, the lowest it goes is negative 1. Cosine, same thing, except for I'm going to be graphing the x values. At 0, it's 1. At pi over 2, it's 0. At pi, it's negative 1. Back to 0, then 1. 0, negative 1, 0, 1. And it bounces. Some of my kids say that it looks like a W. I say cosine starts in the clouds because if you're standing down here and this is the sand, sine starts in the sand, then cosine starts in the clouds. Domain, all real numbers. Range, again, negative 1 to 1. Tan is sine divided by cosine. So it's the y value divided by the x value. So 1, 0, 0, 1, negative 1, 0, 0, negative 1. At 0, it's 0 over 1, so it's 0. At pi over 2, it's 1 divided by 0. That's undefined, so there's an asymptote there. And then it's 0 divided by negative 1 is 0. Then it's an asymptote. So this one's pattern is it goes 0, asymptote, 0, asymptote. So it's asymptote, 0, asymptote, 0, asymptote, 0. And if you go in farther, the tangent at 45 or at pi over 4 is 1. And then here is negative 1. And then 1, and then negative 1. So it's 1, negative 1, 1, negative 1, negative 1, 1, negative 1. And it actually ends up looking kind of like an x cubed graph on the inside of that. I can't draw these well. Okay, its domain is all real numbers except for the asymptotes. Well, my first asymptote is at pi over 2 plus or minus pi k. Why plus or minus pi k? Well, because it takes pi to get from here to here. That's the distance of pi. Well, to get from here to here, that's the distance of pi. Well, that's the distance of pi. So if I started at pi over 2 and I added 1 pi, I would get here. If I added 2 pi's, I'd get here. If I added 3 pi's, I'd get here. So that gives me every asymptote. And the range is all real numbers. And now we're going to go ahead and skip and start translating some. The amplitude is your distance above and below the graph. I have to sneeze. I'm going to pause it. Okay, I sneezed. Distance above and below the graph. And the amplitude is the absolute value of A. It says to graph 4 cosine of theta and cosine theta on the same set of axes. Well, in my period, I'm going to label my ends right now as negative 2 pi to 2 pi. Cosine starts in the clouds, and it bounces here. And this is regular old parent graph of cosine. Okay, that's y equals cosine of theta. Well, for cosine of theta, it stretches the graph vertically. So instead of going up and down to 1, because this is understood to have a 1 under it, it's going to go up and down to 4. 1, 2, 3, 4. And what I do is I draw little amplitude lines. I usually like to do it with a ruler. Just to kind of, these are like guidelines just to keep me, I'm just trying to keep it between the lines. So I'm going to start, instead of going up to 1, I'm going to go up to 4. 0, negative 4, 0, 4, 0, negative 4, 0, 4. And it just stretches my graph vertically. Okay? And if that had been a -4, it would have flipped the graph. Everywhere it would normally would have went above, it would have went below. So I'm actually going to skip that example and go straight to talking about the period. The period of a graph is defined as how long it takes the graph to get back to where it started. Okay, on a cosine graph, it'd be how long does it take to get from top to top. And what the period does, it takes 4 tick marks to get back to where it started. So, let me go here. If it's y equals, so far, a, either cosine or sine, of b theta. B is defined as 2 pi divided by the period, or you could say the period is 2 pi divided by b, because the actual equation is bp equals 2 pi. It doesn't matter what you divide by, you're going to get the same equation. So, right now, b is 4. So the period is 2 pi over 4, or pi over 2. All that does is labels your ends. That's it. It actually stretches and shrinks the graph, but that's pretty difficult to actually graph that, so we just label the ends and graph our regular old cosine graph. The only difference is my ends are labeled differently. Regular old cosine, amplitude of 1, and I just sketch it, and I'm done. Okay. This one has an amplitude and a period. I just go down the side and start putting my stuff. My A is 3, my B is 2, my period is 2 pi over 2, or pi. So I label my ends with pi and negative pi. My amplitude is 3, 1, 2, 3. I'm going to draw my little amplitude lines up here and here. And it's a cosine graph. Cosine starts in the cloud, so I'm going to start at the top, and then I'm just going to bounce. And sketch. Okay. Write the equation of the cosine function with amplitude 9.8 and period 6 pi. Well, A is 9.8 plus or minus. The amplitude, if the amplitude is the absolute value, I have to say plus or minus because I don't know what it was. And it gives me my period. Well, my b is 2 pi divided by my period, so my b is 1. So it would be y equals plus or minus 9.8 cosine of 1 theta. Alright, now I'm going to start shifting them. It says state the phase shift for each function, then graph the function. I go ahead and put everything A, B, P, PS, and we're going to go ahead and add in the C on the end. A is 1. B is the number that's in front of the theta because it's A sine of B, theta minus the phase shift, plus the C. Well, the B is 1, so my period is 2 pi. My phase shift is, if I plus a number on the inside of the parentheses, it moves left, pi, and then I do not have a C. Okay, so I label my ends with 2 pi, negative 2 pi. My amplitude's 1. Okay, and I'm moving left pi. Well, what I do is I actually go ahead and move my y-axis. Left pi. Well, if 4 tick marks is 2 pi, then 2 tick marks is pi. And then I just graph my regular old parent graph right here. Sine starts in the sand, and it just bounces. I think that I'm going to run out of time. I don't want this video to go over 10 minutes. So I'm just going to do one where it has a vertical shift really fast, and I'm going to stop for this video. If I need to make another one, I will. I'm going to extend this down 1, 2, 3, 4, 5, 6, 7. Okay, so A is 2, B is 1, so my period is 2 pi. My phase shift, I don't have one, there's nothing in the parentheses, and my C is negative 5. What that means is the minus number on the outside goes up or down. So 1, 2, 3, 4, 5. I'm going to draw a new x-axis. It's just the easiest way to do this. I'm going to move my tick marks down here. 1, 2, 3, 4. 1, 2, 3, 4. My period is 2 pi. I always have to label my ends. My amplitude is 2. I go above and below it by 2 and put my little guidelines here and here. And then I just draw my regular old cosine graph on my new location. Cosine starts in the clouds. Uh-oh. Okay. And that's it. I'll make another one with the more complicated, putting it all together, like